Okay, if you're looking at your 17.1a notes, you'll find this at the bottom of page 2. It's an optional review for those of us who are having troubles with remembering how to simplify radicals. There's definitely more than one way to do it. You don't have to do it my way, but you have to show me some work for it so that I know you don't just have a calculator that simplifies radicals for you. My preference on how to do this is to use a factor tree. So if I start with the square root of 50, I'll say what goes into 50, and you can start with any two things that go into 50. I'm going to start with 5 and 10. Here's 5, here's 10. 10 can break down a little bit more. I'll say 5 and 2. Okay, now using this technique, what I need to look for is, what about pairs? Anything that has a single matching piece becomes a single number in your answer. This 2, he's got nothing. He goes inside the radical, and that's my answer for that problem. Some people would prefer to say always start with the smallest thing you divide by. Another way to do the same problem is to say square root of 50 is equal to, square number that goes into it is 25, so 25 times 2. Since I know that the square root of 25 is 5, I can put the 5 outside. There's no perfect square root of 2. It's a crazy decimal. We can go another way to get the same answer. Let's look at our next example. Square root of 54. What goes into 54? This time I'll just say it's even, divide by 2. Square root of 2 is, 2 divided into 54 gives me 2 and 27. What goes into 27? 3 and 9. What goes into 9? 3 and 3. Again, I'm looking for pairs of matching things. I see here a pair of 3s becomes a single. I got another 3, but he doesn't have a partner, so he doesn't get to come out. Then I have these leftover 2, leftover 3, square root, leftover 2, stuck inside, leftover 3, stuck inside. That means 3 square root 6. Good. If I had wanted to do it by the other technique, which you certainly don't have to know both techniques, know one of them or the other, I would say, I know 9 is a perfect square, and 9 goes into 54. So I'm going to take square root of 54, change it into the square root of 9 times 6. And there are no perfect squares that go into 6, so I'm done with that part. Square root of 9 is 3. Leftover 6, can't split up well, stays here. Same final answer. Okay, last one. Square root of 72. I can start with anything that goes into it. Most of us see 8 times 9 as our first choice. Neither one of those is prime, but that's okay. We don't need it. We can just go 8 times 9. 9 goes down to 3 and 3. 8 goes down to 2 and 4. But the 4 can split again. I'm looking now for pairs. Pair of 3s. He gets to go outside. Pair of 2s. He gets to go outside. Like this other 2 doesn't have any pairs. Every once in a while I hear somebody say, well, what about the 8? What about the 9? As long as they're not the ends of the branches, we don't have to worry about them. We only deal with ends of branches when we're looking for pairs here. Okay, so I'm back here saying 3 times 2 on the outside is 6. Leftover 2 on the inside, 6 root 2. Okay, that is the basics of simplifying radicals. two different methods. Let me show this one by upside down division instead. So what if I took 72 and I said, what goes into 72? 2. If you're using this technique, make sure you always choose the smallest possible number that goes into it. 36 times. What goes into 36? 2. 18 times. What goes into 18? 2. 9 times. What goes into 9? 3. 3 times. If you look at this carefully, you can see we've got that pair of 2's, got that pair of 3's, the same thing as we got up above from the branches, the ends of those branches. And then I got this other 2 that's going to have to stay inside. 2 times 3, left over 2, 6 root 2, same answer. Okay, that's about all I have to say on simplifying radicals. Now I'm going to go back and work out the rest of the Mod 17 notes. If you're struggling with simplified radicals, come back to this. There's a typed version of the same thing if it's better than my handwriting. But I'm moving on. Don't forget to watch the rest of the 17.1 notes.